Hi dear students, good morning to all. Dear students, in the previous part of this video online lecture series, we discussed about the two types of the important devices, particularly nuclear reactor, and based upon the nuclear reactor, we discussed about the power reactor. Dear friends, in the previous part, we discussed in detail about the construction and the working of nuclear reactor, in which the nuclear fission of the various nuclei is carried out under controlled manner, and it produces a large amount of energy. We call it as the nuclear energy, and this nuclear energy is utilized to form the steam, and the steam is used to generate electric power with the help of turbines through the generator. So in the previous part particularly we discussed about how we can convert nuclear energy into the electrical energy or the electric power, and the device which is used for this purpose, for this conversion, is called as the power reactor. Definitely there is nothing difference between power reactor and the nuclear reactor, because in the nuclear reactor we carried out a nuclear reaction in controlled manner to obtain large amount of energy, and this is the chain reaction. But whenever this nuclear energy is utilized to get electric power, then the device is called as the power reactor. So dear friends, today in this part of this video lecture we are going to talk about the another type of the reactor. We call it as the breeder reactor. So here earlier this we discussed about the nuclear reactor and the power reactor, but in this topic we are going to talk about the breeder reactor. What is the main difference between nuclear reactor and the power reactor, or power reactor and the breeder reactor? This that we will discuss today in this part. Dear friends, if you remember about the power reactor, then we are using some nuclear fuel, and with the help of nuclear fission we are getting the nuclear energy, and this nuclear energy can be utilized to obtain the electric power. But for that purpose definitely we has to provide some amount of nuclear fuel, and this nuclear fuel later on is used to obtain the nuclear energy, and that will convert it into electric power. But whenever we are getting the nuclear energy, then at that time there is a disintegration of, or there is a breaking of the nucleus particularly, and definitely the nuclear fuel is consumed. And definitely how much amount of nuclear energy is obtained, if you will discuss the efficiency of this power reactor, definitely it will not be more than 100%. It will be less as compared to, means whatever amount of nuclear fuel is provided, we are not getting the exact amount of nuclear energy. So this is the important thing. Actually today in this part we are going to talk about the breeder reactor. What is the breeder reactor? It is again a nuclear reactor. This is also the nuclear reactor. Definitely we are going to talk about the nuclear fission in controlled manner in this type of the reactor also. But in this case the nuclear reactor is designed in such way that it produces more fuel. It produces more fuel than it consumes for power production. It's very important that, means suppose I can give you the one example for the of any vehicle or the bike. Suppose we are expecting a particular mileage or the particular average. For example, for 1 liter of the petrol we are getting the 70 kilometer, then expected average is 70, but we never get 70. Generally we are getting the less than 70, either we are getting 60, 65, what it may be, but it always less than 70, which is given by the company, particular company, for the particular vehicle. But it is never possible. Suppose any one particular company have given the average for the particular vehicle is 70 kilometer, and suddenly we will get the 80% or more than 70%. It is not possible, and this is possible in this nuclear reactor called as the breeder reactor. It's very important, and that's why the nuclear reactor is designed in such way that it produces more fuel. Means this is the recycling. You can say this is the recycling of the fuel. Then it consumes. Definitely for the power production, the reactor must consume some amount of nuclear fuel, but whatever consumption is there, more than that is than the consumption, it produces more. Suppose it consumes 10 atoms of a particular uranium 235, then for the power production, then during the same process it will produce 15 atoms. It means that it has consumed 10 atoms, but at the same time it has produced 15 atoms. So whatever consumption is there, definitely the consumption is smaller and the production is greater. That's why this device is called as a breeder reactor. In this reactor, the fuel, the amount of nuclear fuel or the nuclear fuel goes on increasing. Means whatever initial amount that we have provided, its amount goes on increasing during the power production, and that's why this is the characteristic of this breeder reactor, in which the amount of nuclear fuel goes on increasing. And in this case, what nuclear fuel actually used, and it is observed that the small amount of uranium 235 is used along with the uranium 238. So these are the two nuclear fuel which are used in the breeder reactor. Uranium 235, small amount of uranium 235 is used along with the 238. So in this case we are using the mixture of uranium 235 and the uranium 238. Definitely how it works, that is also important, or how it increases the amount of nuclear fuel in this breeder reactor, that is also the part of interest here. So here we should discuss about how it increases the amount of fuel in this breeder reactor. In this case, what happens, the uranium 235 is bombarded with the slow neutron. It undergoes the fission. Definitely it will broken down into two nuclei. One is barium 141, another one is the krypton 92, and at the same time it producing the three fast moving neutrons and the large amount of energy. Here we can see the reaction. Uranium 235 is bombarded by means of this neutron, that is neutron in the sense uranium 236. Later it will be converted into, so this will be this converted into uranium 236, and it will be broken down into two parts, barium 141 and krypton 92, with the liberation of fast moving neutrons, three number of fast moving neutron and the liberation of large amount of energy, 300 million electron volt. So this is the simple nuclear fission process. But in this reaction we are getting the fast moving neutrons, slow moving neutrons are bombarded on the uranium 235, that will broken down into two smaller nuclei, barium and the krypton, with the liberation of fast neutrons and the large amount of energy. Here these fast neutrons which are formed in this nuclear fusion, these fast neutrons can be converted. This fast neutron convert fertile material uranium 235 into fissile material. So the uranium 238 is the fertile material, means it will not undergo fission directly. First of all, it will be converted into fissile, and then it will produce a large amount of energy whenever bombarded with the slow neutron. So this fast neutron convert this uranium, means the fertile material, into fissile material. What is this? The plutonium 239. So this fast neutron bombarded on this uranium 235, it should be 238. I should make this correct. So this is uranium 238. When bombarded by neutron, it will be converted into uranium 239. Later it will become neptunium, and finally it will be converted into fissile material, plutonium. It will undergo fission directly and produce with the production of large amount of energy. Similarly, thorium 232 can be also converted into fissile material uranium 233 by the bombardment of neutron. This is the same process like the earlier one. Here we can discuss about the same. This just uranium 232. It can be converted to uranium 233, and later it will be converted to polonium into uranium. So this is the fissile material. So it will undergo fission directly, and this is the fertile material. So this fissile material is generated from fertile material. This is fissile material generated from fertile material, and hence the name is called as the breeder reactor, or it is also called as the production reactor, because in this reactor we are producing a fissile material from the fertile material. We are converting fertile material into fissile material. That's why it is also called as a production reactor, and hence the amount of nuclear fuel goes on increasing in this type of reactor called as the breeder reactor. Dear friends, after this I hope you got the clear idea about the breeder reactor. In the breeder reactor we are using the fertile as well as fissile material, and the whatever neutrons obtained in the nuclear fusion, these neutrons are responsible for the conversion of fertile material into fissile material, and that's why the amount of nuclear fuel goes on increasing in the breeder reactor. That's why this reactor is also called as the production reactor. It's very simple to understand about the breeder reactor, because this is a simple concept whenever compared with the nuclear or the power reactor. In the nuclear or the power reactor, the fission of the nucleus take place, heavy nucleus take place whenever it is bombarded by the slow neutron, and we are getting the large amount of energy. So here in this part we are also going to talk about the reverse process of the nuclear fission, and that reverse of nuclear fission is called as reverse of the nuclear fission is called as a nuclear fusion. So combination of nucleus is called as the nuclear fusion, and similarly whenever the two or more nuclei of low binding energy per nucleon, it's very important, two or more than two nuclei of low binding energy per nuclei combine to form larger nucleus with higher binding energy per nucleon. So this is the important thing, and a small amount of mass get converted into very large amount of energy, and this process is called as the nuclear fusion. I hope you can understand. So whenever the two or more than two nuclei of low binding energy per nucleon combine to form larger nucleus, or the large nucleus having higher binding energy per nucleus, and small amount of mass get converted into large amount of energy. So this is the combination of the smaller nucleus to form the larger nucleus with the formation of large amount of energy, and this process is called as nuclear fusion. So here you can see here, this is one of the reaction in which 4 hydrogen nucleus get combined to form the helium nucleus. Definitely it is larger and it is the smaller, but during this process there is a formation of large amount of energy, 26.7 million electron volt. That's why this process is called as the nuclear fusion. And for such nuclear fusion reaction, a very high temperature, generally of the order of 100 million electron volt, is required to overcome the electrostatic repulsion between, or electrostatic force of repulsion between the protons which are present in the nucleus. And that's why in order to overcome this repulsive force, we are requiring the very high temperature, generally of the order of 100 million electron volt, and hence the nuclear fusion reactions are also called as thermonuclear reaction. Why this is so? Because this nuclear fusion requires a very high temperature, and that's why it is also called as the thermonuclear reaction. So it's very important that whenever we want to combine the two nuclei with one another, the repulsion between the proton present in the nucleus of both the nucleus must be diminished, must be overcome with the help of temperature, and for that purpose we are requiring very high temperature to overcome the repulsive forces between the protons of both the nuclei, and that's why these nuclear fusion reactions are also called as the thermonuclear reaction, because it requires very large amount of temperature. That's why these are called as the thermonuclear reactions. So dear friends, today in this part of the video we talk about the two important thing, or the two important concept. One is called as the breeder reactor, in which the amount of nuclear fuel goes on increasing, And the second one is called as the nuclear fusion, in which two or more than two nuclei with low binding energy per nucleon combine to form larger nucleus having higher value of binding energy per nucleon, and with the formation of or with the liberation of large amount of energy, or with the conversion of small amount of mass into larger amount of energy. And that's why this process is called as nuclear fusion. And definitely it requires very high amount of temperature, very large temperature, and that's why these are reactions are also called as a thermonuclear reaction. Definitely in the nature also many thermonuclear reactions are always occurring, either in the galaxy, in the universe. Definitely natural thermonuclear reaction, nuclear fusion reaction always take place, and we sometimes we are not aware about these reactions, but it is again interesting, as well as it is again more important to know what are the nuclear fusion reactions that take place in the universe, in our surrounding, in our, that is whatever, in our life. So we should be aware about this reaction. So in dear friends, in the next part of the video we will talk about some examples of the nuclear fusion reactions or thermonuclear reactions. So we will resume again in the next part to discuss the last part of this topic, called as the examples of different thermonuclear reactions. So thank you all, thank you once again.